Hello and welcome to this educational video about real-time systems. In this video, we are hoping to discuss about the basics of real-time systems. This will include an introduction to real-time systems, characteristics of real-time systems, usages of real-time systems, what counts most in real-time systems, and also the relationship between real-time systems and embedded systems. Then we will concentrate more on the serious stuff like design methods of real-time systems, real-time programming, programming languages used in real-time programming and their special features, and not forgetting the subtopic, a case study in Java. We will dive deep in real-time programming through a classic case study in Java, that is inverted pendulum implemented in Java real-time specification. But since this is the first part of our video, we will include the basic things about real-time systems. And of course we will discuss the more complex matters in the second part of the video. Now then, let's get started with our video. Introduction. Computers are used to control a wide range of systems ranging from simple domestic machines to entire manufacturing plants. These computers interact directly with hardware devices. The software in these systems are embedded real-time systems that must react to events generated by the hardware and issue control signals in response to these events. It is embedded in some larger hardware system that must respond in real time to events from the system's environment. The term real-time derives from its use in early simulation, while current usage implies that a computation that is fast enough is real-time. Originally, it referred to a simulation that proceeded at a rate that matched that of the real process it was simulating. Analog computers especially were often capable of simulating much faster than real time, a situation that could be just as dangerous as a slow simulation if it were not also recognized and accounted for. Now let's take a look at what a real-time system is. Real-time systems are different from other types of software systems. Their correct functioning is dependent on the system responding to events within a given, usually short time interval. There are several technical definitions for real-time systems. For an example, following is the Ian Somerville's definition for real-time systems. However, this is not a strict definition since there can be several ways it can be expressed. Now here you can see several more examples for different definitions, all of which are correct and pointing to the same thing. This is the definition you find in the Oxford Dictionary of Computing. And this one is from a scientist named Young. All these definitions highlight the same thing, and it is the vitality of the timely responsiveness that makes the real-time systems different from other software systems. There are two main differences among real-time systems, and they are categorized into two categories according to these two differences. In the case of these subcategories, also there could be several different definitions. First of all, if we consider soft real-time systems, a soft real-time system is a real-time system that does not hold a very high stake on timing constraints. Even though timing requirements are not satisfied, the results won't be catastrophic. Examples for soft real-time systems include ATM machines, household appliances, consumer electronics, and so many other electronic devices. Nothing severe will happen if the output of these devices are not produced according to the deadlines. Therefore, these systems are considered soft real-time systems. And the next category we consider is the hard real-time systems. The hard real-time systems, which are quite different from the soft real-time systems, requires a unique consideration about the timing constraints of the systems. Hard real-time systems are quite different from the soft real-time systems. In hard real-time systems, meeting the timing constraints are absolutely vital. Otherwise, the result could be catastrophic. Examples for hard real-time systems include controlling systems for chemical manufacturing, control systems for nuclear power plants, and missile guidance systems. Now let's take a look at other classifications of real-time systems. What are other classifications available for real-time systems? Real-time systems can be looked at as a stimulus-response system. Given a particular input stimulus, the system must produce some corresponding response. The behavior of the real-time system can therefore be defined by listing stimuli that are received by the system and the associated responses and the time at which the response must be produced. The stimuli falls into two categories: periodic stimuli and aperiodic stimuli. Periodic stimuli in a real-time system are usually generated by sensors associated with the system. These provide information about the state of the system's environment. The responses are redirected to a set of actuators that control some hardware unit that then influences the system environment. The other class of the stimuli, aperiodic stimuli, may be generated either by the actuators or the sensors. They often indicate some exceptional condition, such as a hardware failure, which must be handled by the system. The real-time system has to respond to stimuli that occur at different times. Its architecture must therefore be organized so that the control is transferred to the appropriate handler for that stimulus as soon as it is received. This is impractical in sequential programs. Real-time systems are therefore normally designed as set of concurrent cooperating processes. Part of the real-time system is dedicated to managing these processes.